let's start with some slides. If you have any questions, feel free to throw those in the chat. I've got chat here. I'll kind of pop back and forth. And also feel free to interrupt me with questions if I'm not doing that. So we can certainly take questions. And also feel free to hang on to those for the end of the presentation. I can address them then. Whoops, let's go back here. Okay, so my name is Jeremy Davis. I'm a principal architect at Red Hat. I have been using Java. I just realized watching the Java Future of Java is You presentation today. I first started using Java right around the turn of the century when I was starting out as a mostly JavaScript web monkey at the time. I was developer, team lead, architect for a number of years, joined Red Hat 13 years ago, and since then I work with customers across a lot of different verticals, a lot of different industries, and work with Red Hat's engineering teams, and occasionally speak at conferences. And so today I'm going to talk about 7 strategies for building majestic monoliths and maybe avoiding some craziness that comes along with microservices. You have my bio and stuff. If you want, feel free to email me if you want to contact me. You can also find me on X or Twitter, on Instagram and Mastodon. I have a Threads account too. I guess I should put on there, but I've had a hard time with Threads so far. But feel free to reach out if you have any questions or want to talk about anything in the presentation. So when microservices first came out, right, this is the image of the microservices Death Star. I became really enamored with the concept of microservices, as I think most people did in the industry. I'm guessing that if you're attending this talk, you probably have written or are writing a lot of microservices applications. And microservices, as you know, we began building with them, learned that they can be kind of difficult. Martin Fowler, who coined the term, said that you shouldn't start your application with microservices. He said that you should start your applications building a monolith, and then you can pull microservices out of that if you want. That seemed a little bit easier said, I thought, or like a better in principle than maybe in practice. Although I do think you can do that very easily, which is also the basis of this talk. Now, the phrase majestic monolith came out. David Hannemeyer Hansen, in case any of you follow his blog, he's always a good read, has a lot of interesting opinions. He's the guy that invented Ruby on Rails. If you remember, like early in my career, you know, I was a Java guy, and that video of Rails came out, and you know, somebody just generating the scaffolding for this application so fast. And I remember thinking, I've got to learn this technology. And that's also how I learned Ruby, which I also like. I like Ruby as a language too. But the concept of being able to generate that scaffolding and be very opinionated has made its way throughout all, you know, really every language and frameworks that we use today. So I like that a lot. I've kept tabs on what DHH writes, and he wrote this this blog post called "The Majestic Monolith." And the gist of his blog post was he said that people kept asking him when he was going to refactor his applications. His company makes SaaS software, and when he was going to refactor his company's applications to microservices. And his answer was, I'm not going to ever do that. And his justification for not moving to a microservices architecture was that they roll to production every Friday. And he said, so at his company, you get an idea gets accepted, and the following Friday it's in production. And that's fast enough for his company. And so he said, we don't have to move any faster than that. 5 days, you know, to get a feature into production is plenty fast enough. There's no reason for us to take on the added complexity that microservices bring. Now, early projects that I began working with customers on microservices were largely based around performance, and that's a very different angle because you can pull out. Obviously, if you're building things, let's say in an application server, right, or a Spring Boot application, however when you're building a monolithic application, everything that application does has to be scaled in the same manner, and that can be difficult if the application is doing a number of really different things. And so, the first application that I helped break up into microservices, part of it was a very kind of simple, traditional web, CRUD front end where people would basically babysit a database. But then there was part of it that did a lot of processing, and the processing part of the application would chew up a lot of memory for brief periods of time. So that was a great candidate for splitting something up into microservices, and that makes a lot of sense. But in terms of but typically, I think when people go down the path of developing in a microservices architecture, it's around features, and it's done so that we can change individual parts of the application really quickly. So from the DHH perspective of, we can build a monolith that is really nice and it's easy to use, and we can get features into production on a Friday. He then extended it with this concept of the Citadel, and that's we've also talked a lot of times about the strangler fig pattern, which is a way that you can pull the microservices out of an existing application. But I like this concept of the Citadel because that sort of Citadels and Outposts, and it starts from the notion that we know we're going to we're going to break our monolith up into microservices, but we're going to start with a monolith and we're going to build it in such a way that when it does come time to break it up, it's going to be very easy to do. And so that's the application we've got. So I'm going to now look at like 7 things we can do to make this easier or easy. And actually, let me show you the application that I have running first. So let's take a look at that. The application that we're going to look at here is an application I built called the Quarkus Coffee. Whoops. All right. Called the Quarkus Coffee Shop. This is originally a microservices application, event-driven microservices application, built around Quarkus, which is Red Hat's Java runtime. There's only one Quarkus-specific piece of this. If you haven't seen Quarkus before, it's no big deal. I'll explain that when we come to that. So this coffee shop is pretty similar. You can see we have all the basic things we get in a coffee shop and the basic, barista and bakery. Now this is our board that'll tell us when our orders are ready. So I'll order a black coffee. I usually drink coffee black, and I'll order a croissant here, and I'll place that order. And so these are both in progress. And so my coffee is now ready. Mr. Spock has prepared my coffee, and Mr. Sulu has prepared my croissant. And we got some other stuff. These are our baristas here, guys that build Quarkus. So that's our application. So this is a monolithic application. It's communicating over JavaScript back to one monolithic app. We'll take a look at it here. And here's our application, which we'll jump into some of this stuff again in a minute. But let's come over to our application. The first thing we want to talk about is code quality. So let's do a Maven clean and test. And so I'm just running a Maven test. We're going to run our tests here. And while that's running, we'll jump back to the slides here. So all right, so first things first is code quality, right? And code quality, it doesn't really matter, I don't think, so much how you use it. I just think it's really, really great to have some code coverage and look at your code coverage. There's a lot of different tools that you can wire into your build. You can fail your build. I have worked places that failed the build on test failures or on coverage. I think that's a little bit tough. Certain things I don't really care, like getters and setters. It doesn't matter to me if they're covered. I also think it's really nice to use some of these things just on your own, like before you decide to send a pull request in. So look at your project mess detector, find out how things look. Look at spot bugs. Some of the stuff it's going to catch isn't really a big deal. Some things are a bigger deal. So let's say this stuff is wired into my application, so we should have a Control-O. And we'll go to my demos, Quarkus Coffee Shop Monolith. If you haven't used these kind of plugins before, it will be in my target directory. There's my JCON report. And you guys see this, font's probably a little small. So did my test fail? Yeah, my test must have failed. So because I had 0 coverage here, and I definitely should have some coverage here. So yeah, something. Barista test, make black coffee. Failed. 11 tests runs ago. All right, so clearly something needs to be fixed in my test, which is a great reason to run this. And honestly, if I ended up with 0 coverage, I would probably fail my build on that for sure. But if this is mostly green with a mix of things, and I can see like which things get covered and which things don't get covered, then I wouldn't always care. So for instance, some methods I don't care about, but in general, I do think you should have code coverage. Wire your code coverage, into the application, and use that as part of your build process. Whether you're going to fail, part of your tests, or if you're just going to look at them before you make your commits. Second piece is continuous delivery, right? Now, I know a lot of us work inside of the enterprise. I mean, if you work for, a startup, you can probably push to production daily or weekly, more frequently. Oftentimes, the enterprise, most of the customers that I work with, about half of the places that I worked, are still not really comfortable with the notion of going to production constantly. And so what I think a better approach, or an approach that everybody can take, is be able to go to production at any point in time, meaning, build all the time, run your test cases, run integration tests, be able to deploy continuously. And I think that is something that most people can most people can pull off. And really, all this boils down to have some sort of way that you build. GitHub Actions are kind of my new favorite thing. I think they're great. I used to use Tecton pipelines a lot. Jenkins, obviously. There's plenty of different ways that you can do this. GitHub Actions is the easiest way to get started, right? Because it's right there next to your code. You probably think GitLab, you can do the same sort of stuff, right? But run your test cases, do your build, run your test cases, get your reports run. So every time that you check in, and you can set these up differently too. So depending on what, if you're branch or are you on main, but absolutely set up continuous delivery and be ready to go to production at really any time. All right, so now number 3, domain-driven design. So when domain-driven design, this is an old idea, and this is the fun part of the presentation, because we can look at some code now. Domain-driven design is not a new idea, right? It popped up 12 or 13 years ago, I think. So around 2010, I believe, is when the Eric Evans book came out, and it received sort of a new lease on life, or it got a lot of press again when microservices came out, because people began to talk about how microservices often line up with the concept, the DDD concept of bounded contexts really nicely. So in this application, we just saw my coffee shop application, we have a barista. There's obviously a web front end. There's a kitchen. And there's a counter that sort of orchestrates all the work that happens. And in a microservices architecture, this can all become part, each microservice, right? But in a monolith, that's going to be a little bit different. There's also some other constructs from domain-driven design that we'll look at, like aggregates, value objects, services, and repositories. These make a lot of sense inside of a microservices architecture, and starting them inside, but they make a lot of sense inside of a monolith as well. And adhering to them makes it a lot easier to pull things out. Let me pop back over to my code, and let's take a look at what some of this actually means. Go to IntelliJ here. And so let's go to view, appearance, presentation mode. And let's see. So the first thing in my Java, I have a coffee shop domain. If you notice, I have each bounded context has its own package. And then inside of that package, I've got an API that I publicly exposed. I'll talk more about the APIs in a second. But this exposes all of the functionality to the rest of the application. And then I have my own domain objects. I have some shared domain objects here inside domain. And the reason for that is ultimately, if you're going to break these into microservices, so when I break this barista out, it's going to carry all of its domain objects with it. I'm not going to have a shared jar file, because you don't want to have coupling between your microservices. But inside of a monolith, I think it's more of a pain to sort of marshal everything across packages. So I think having shared objects is fine when you're inside of the monolith. Just pull those out when you go into when you break out your outposts. And then we also use like the commands. Let's see, a place order command. This is a domain-driven design construct, if you're not familiar with that. Place order command. These are just immutable objects. Actually, this should be refactored to a Java record. But you want to have immutable commands, and commands kick off all of the events that happen. So the application is still built around events and using events, even though it's inside a monolith. When you break that out, you would use something like Kafka, and I've got Docker Compose running with Kafka ready to go. So when I pull this barista out of here, then we'll be communicating through Kafka. But each of these, and then each of these also has its own. I mentioned I'm inside of Quarkus. So inside of Quarkus, the way you configure a data source is you put it in here. And I have a different data source for each of these bounded contexts. So I've got a barista data source, and then I have a kitchen data source and counter data source. The idea behind this is eventually I'm going to need different data sources anyway. So when I split things off, I'm gonna need to have different data sources when I break this into microservices. So you just go ahead and start, and you can just use a different schema. It doesn't, that's fine. But just make it so that you're not relying on the same kind of things. So the first thing is, structure your packages around your bounded context. And it's okay to have shared domains or some shared utilities, right? Would caution, though, that when you do eventually split this off into an outpost or into a microservice, don't have a shared coupling. But it's okay at the moment. The second thing is use your domain-driven design constructs. Treat each of your packages as a separate domain. Use value objects to communicate across those things. So inside my barista, anything I'm going to persist inside that barista package, I'm only going to send back immutable objects. Actually, let me take a look at that too. We'll just come into my barista here. Actually, these are void methods. But inside my, let's say, kitchen API, I have all void methods here too. So counter. I'll show you. All right, I'll hang off on why I use void stuff in the moment. But I am passing across immutable objects. So I'm getting messages, or I'm getting immutable objects. I'm not passing around my domain objects, right? My domain objects live only in their individual packages. All right. So number 4 is APIs first. I just jumped over to my API package there, so we saw some of that. And I have to give a shout out to one of someone at the Atlanta Jug Group. So I live in Atlanta, Georgia, which is in the southeastern United States. And the local Jug Group we have a really active Jug Group. One of the organizers of the Jug gave a presentation a long, long time ago. So I was pretty young or pretty new when I saw this presentation that he gave. And he talked about the importance of APIs and user experience. And he started off the presentation by asking how many of us were involved with front-end code. Well, being Java developers, most of us were not involved with front-end code. Most of us did back-end code. So a few people raised their hands. And then he asked who did back-end code. Like, everybody raises their hands, right? So we all did back-end code. And then he asked if our code was consumed by other people. And again, we pretty much all raised our hands. And he said, so even if you're writing back-end code, you have users. Your users are other coders often, but you have users. Do you think about user experience and API in that way? And it really changed the way that I like writing code. And so some of the recommendations he made was to have an API package and then expose any of the functionality that you want outside of that package through that API. And that dovetails really nicely with this notion of domain-driven design and bounded contexts. So I have this barista bounded context, and I have an API, I have a barista interface in my API package, and those are the only public methods inside of that package. And so it enforces a break from the rest of the application because another part of the application can only call in through that API package. Some other stuff is kind of just basic good programming practices. But the notion of treat your APIs, we often think of APIs as being like a REST API, right? Or GraphQL API. But APIs can also just be an interface that's exposing public methods out to the rest of your Java class. And inside of a monolith, you're setting yourself up for a nice, clean API that can then be extracted outside of your application. So number 5, autonomous data. And I think I already touched on this a little bit, but one, don't worry about having lots of data sources, right? So I have different schemas for each of my bounded contexts. It is overkill, and it can be a little bit clunky when you're building a monolith this way. But when you go to break these out, it's going to save a lot of time. You're ready to go, right? Don't have your different domains persisting other objects. So communicate across domains using immutable objects, and then let everything be in charge of its own data source. And that also goes, and that means when you do go to microservices and you move into that notion of every microservice is in charge of its own data, you're already ready to go with that. And that's often one of the hardest parts about building microservices. And one of the things that I think a lot of teams forego, and it's okay to do that. But shared data sources are often very, very common. So if you're able to start greenfield and have separate your data sources, by all means, take advantage of that ability. All right, so number 6, so avoid bottlenecks. So one of the things you can do in a microservices architecture, like when it started off, right, everybody was using the Netflix API, the Netflix utilities, right? So we were making HTTP calls. Well, HTTP calls, are blocking, right? You're doing a request and response, and you have to wait for your call. Well, Kafka has taken over, or other messaging paradigms, but Kafka makes it really nice and easy way to use as a transport, because you can build asynchronous applications, and you can build event-driven applications, right? So you can just publish an event, like somebody orders a beverage, you can publish an order in event. So, hey, an order has been placed, something needs to happen. And you can do that asynchronously through messaging. Now, you probably don't want to use messaging to talk back and forth through a monolithic application, right? We're in memory, we're running in the same memory space. So that would be overkill for us to be able to do that. But what you can do is write reactive code. Now, reactive code can be kind of complicated. I spent a lot of time using RX Java. I really like this concept of reactive code. RX Java was started by some of the guys at Netflix. If you haven't familiar here, pop that up. So RX Java. Gee, let's see, where is RX? Yeah, it's actually all of the Reactive X. So there's Reactive X in virtually any programming language. So you have all lots of different programming languages. This is the Java one you can download. I find it a little bit confusing. There are other ways to use. There's the Spring Reactor project. If you're in the Spring world, we have Small Rye Mutiny at Red Hat, which is built into Quarkus. And I think Small Rye Mutiny is a little bit easier to use. But it allows you to string. It allows you two different things: unis and multis, which are either one output or a stream of outputs. And so you can use this, and in my case, I'm using a uni on an order. Whoops. I'm using a uni on an order up, right? So we have these methods: order in, remake order. Stop moving. All right. And I'm passing back a reactive method signature. I'm using a reactive method signature. Uni, this is built into Quarkus, and that makes it kind of easy. But like I said, you can use Spring Reactor, you can use RX Java. There's other ways you can do this. Also, Java has this baked in, right? You can use completable futures. But by moving to reactive message signatures, it means that you can then execute these asynchronously, and it'll save you a lot of time. When you then break out your microservice into actual separate calls, this will make it easier to do that, because you're kind of already ready there. You don't have a blocking call that you want to hide behind. So if you can do this early on in your application, it's really great. And reactive stuff, there is a learning curve around it. It is more complicated, but if you can sort of introduce it, gently at the beginning of your application, it will make it easier later on when you swap out backends. Now, another way you can scale out before scaling up, this is a Quarkus specific piece, and I mentioned that I have one Quarkus specific piece because I don't mean to just pitch Quarkus. But Quarkus has, under the covers, Quarkus has something called a Java toolkit called Vertex, which, if you have heard of Vertex, it's been around for quite a while. This is built in under the covers in Quarkus. And Vertex has an event bus. And so one of the things that we can do here is I can communicate through the event bus. Now, this is not a traditional event bus. You don't have to set anything else up. What it allows me to do is it allows me to communicate in memory. And so what I can say here, I can say event bus publish, and this is going to publish to this address, this message, and then that will be picked up by another thing that is listening on that event bus. So I have a consumer for web updates, and then it pushes that out to the web. But it's just listening. I've got a couple that might be a little bit easier to see here. Let's go also. So the way that my barista is consuming an order in is it's consuming an event from the event bus. So I'm not having to make a blocking. I have a blocking annotation here because of the processing I'm doing. But I just consume this off of an in-memory event bus, right? And so this message is coming in over this in-memory event bus. And then when it's done, I can publish it back out to the event bus, right? So this is all happening completely asynchronously. Now I mentioned this is a Quarkus specific feature. Not everything has this kind of feature in it. But you can also use asynchronous method signatures. So that would be another way you could do that so that you don't have to block all your calls. All right, back here. Now, final piece of this is Citadels and Outposts. So we talked about a number of different ways that we can build out these applications before we're going to pull things into microservices. Now we get to the notion of Citadels and Outposts. And the idea of Citadels and Outposts is you have your Citadel, which is your monolith, and then you have your outposts, which are your microservices. So in my application, what this is going to look like, we've got our application running here. We got our coffee shop running. And I stopped my coffee shop, which is fine. So I also have over here, this is my Quarkus coffee shop Majestic Monolith. And then I have a Majestic Monolith with an outpost, and I have my barista outpost. So these applications are the same except for one change. And the one change I have is my barista is now going to consume on the event bus, the same as it was before. And then I'm just going to send a message onto a Kafka topic, right? So both of these, I'm implementing my API. So the other parts of the application, Control V. Yep. So I've got an API that I've coded to. So I can simply swap out the implementation of this interface. The rest of the application won't know what's going on under the covers. And I am talking asynchronously. And so the rest of the application won't know what happens under the covers. And then I'm listening on Kafka. So what I'm doing now is I'm sending something to Kafka here. So I'm going to send this out to a Kafka topic. And then I'm listening to a Kafka topic called orders up, which is when the order is ready. So I'm going to get an order in. Instead of applying the business logic here inside of my class, I'm going to pop it onto a Kafka topic, and the business logic will be applied by a microservice. So let's follow that up. So this is my outpost. So I'll fire up my outpost microservice. And okay, looks like we're good there. And now I guess I didn't need to do a clean and a compile there. Now I'll fire up my monolith that has been modified to work with my outpost. And let's see if this should make no difference in our application. The one difference is the name of my barista who's going to make the drink is just going to take the machine name. So let's come over here. Before, I think Mr. Spock was our barista. And now we'll see who's coming back. This should be, yep, Easter Beagle is the name of my laptop. And so I'm now Easter Beagle local. So I don't have a name. So now this functionality has been pulled out into a microservice. I have two running services. But functionally, the only class I had to change was the implementation of one API. And if we want to we can walk through that a little bit deeper here. Let's do that. Close those two. Start our monolith back up. Actually, let me see. Are there any questions? I didn't open I haven't checked the chat in a while here. Nope. Oh, No, that's from Eric's presentation. Oh, one new message. Okay. So the question, don't you lose advantages of a monolith if instead of plain Java method calls are replaced with async calls with serialization and deserialization? All right, so would you lose the advantages of a monolith by having to replace it with async calls with serialization, deserialization? So depending upon the toolkit you're using, like I'm using Quarkus, there's really no significant serialization that has to happen with the event bus because I'm going through memory, so I'm still passing things by a reference. And using asynchronous calls, like if I'm using Mutiny, and I don't believe with Spring Reactor that it's going to have to serialize or deserialize the objects. So I'm not like going over the wire, right? So I'm still using pass by reference inside of memory. So it should be, so we shouldn't really lose any of the advantages of regular Java, right? It's going to look pretty much like Java, except the asynchronous or reactive calls do look a little weird, but it's not around the serialization. It's just around kind of the programming model. And then Yannick says multi-module Maven projects are a nice way to have stricter boundaries between packages without introducing significant overhead. That's a really nice point. Multi-module Maven projects, you can break these things apart. I personally kind of have struggled using multi-module Maven project. I kind of prefer to have one, but it is a good point, right? And you can have stricter boundaries. You can give each team one of those and package those up together. And I guess depending upon the type of runtime you're using, would dictate a bit of that. All right. So keep an eye on that. And then let's oops. All right, so let's stop the out. We got this one, stop that one, start this guy back up. And we should start debug port should be 5005. We'll walk through the application here. How am I doing on time? 11:30. Okay, we're fine on time. All right. So some of the stuff that's going on, it's creating it's dropping and creating my tables as it boots up. It's Hibernate functionality that's been around for a long time. So let's walk through what happens. Oops, that is the wrong code. So let's walk through what happens here through an app. So coffee shop, come up our web. So kind of place order, and then I'll walk through a couple of these, couple of pieces here. All right, so let's come back here. Oh yeah, I need to attach a debugger, don't I? It's exit presentation mode. Tools. Oops. Run. All right. All right, so the first thing that happens, I've got I mentioned we're talking JSON over an API, right? And so this should look pretty familiar no matter whether you've used Quarkus or not before, right? I have a order, and I have place order. I'm injecting an order service right here. And my order service, I'm going to call this method, right? I could also call it on the event bus would be another way of doing that. But just for illustration's sake here, I'm going to call on order in. We go to this method. So actually, let's just fire forward here. So we'll go to our next method. So now I am in my order service. Now, this goes back to the concept of bounded contexts. And in domain-driven design, one of the really nice things is about bounded context and about what's is the language you use. And you want to work with your business owners to structure the language around the application. And so I've got a place order command. This object that does this is called the counter. And the counter package is based because in a coffee shop, the counter is kind of what orchestrates everything, right? You go to the counter to order, your orders are up at the counter. And so that's kind of where everything goes through there. And so I'm in my counter package, right? So in my counter package, and that's what's going to orchestrate everything. And then my order service, this is another tip. This is a trick that I got, or this pattern or style of code here, I got from Chris Richardson, who has microservices.io. He has a really nice book on microservices, and he uses this pattern. So when I create an order, I need a number of things, right? I need tickets to go to I need tickets to go to my barista. I need tickets to go to my bakery, so the bakery counter, so that we can get the croissants and muffins and stuff. And maybe I need other things too. Maybe I'm going to buy a T-shirt or a mug or something. So when that happens, I also need some updates for the web, right? So instead of making multiple calls, this order event result object is really just a placeholder for other stuff. And so it has an order, it has a list of tickets for the barista, one per beverage for all these various things. And then the order itself has a static method. Whoops, that wasn't the keyboard command I was looking for. The order itself has a method that creates all of this, right? So it creates a new order that I can put inside of the database, right? I can persist this, and then it loops through and creates all the tickets and stuff I need, and it returns this result. Then I can using a repository pattern, I can persist this object. I'm a big fan of the repository pattern. I think Spring made that pretty popular as well. In DDD, you're definitely supposed to use repository patterns, but they don't have to. But I'm going to persist the order itself, so that's going to go into the database, and then I'm going to get the web updates that were created by the order, and then I'm going to pop those onto my event bus. So I'll send all of those. Those will get picked up by the dashboard class that's streaming updates to the front end. I'm going to publish those. And then I'm going to get my barista tickets, and I'm going to get my kitchen tickets, and I'm going to publish those. And the idea behind this is that way my order object itself encapsulates all of the logic, all that business logic around what has to happen when an order comes in is encapsulated inside of the order object, right? It's an aggregate. If we go into the order, in domain-driven design speak, it is an aggregate, right? Meaning it's the top level class. It's got some other stuff. It's got some, child objects here because I am storing, the actual, drinks and food stuff I'm storing in a separate database table, but I'm only ever going to interact with the order itself. And all the logic around what happens is encapsulated inside that object. This object, the service, is simply orchestrating what happens, right? So it knows I call that. It knows that I persist things, and then it knows that I, pop all of these things onto an event bus. So in domain-driven design, services orchestrate what happens, what goes on, and so that's what I'm doing here. I'm orchestrating that. My API endpoint in DDD terms is just it's an input. It's also an output, right? So it's an input, and then I have my dashboard, my web dashboard as an output. And that's often referred to as hexagonal architecture or the ports and adapters pattern, because I have this service, all my logic sort of orchestrated by that service. And then I can put multiple different entry points or exit points. So I could stand up, a JMS queue that did exactly this same thing, right? So I have this is a REST application, but I could have a JMS queue doing the exact same thing. All right, so, and then in my barista, oops, I'm still hanging. We probably timed out. Yeah, we probably timed out. Let's go and kick another one of these off. So there we go. My order. All right, so now I'm in my barista. And the business logic here in my barista is all I'm really doing is I'm gonna wait a little while. I'm just waiting a little while based on what you ordered. Right. So that's the only business logic I have going on here. Right. And then what it's going to do is it's going to pop back. Yep, there we go. So we're done. And now we're going to pop back our order and we should be ready. Yep. We're ready, prepared by Mr. Spock. So that's what the application looks like in monolithic form. Let's come over here and look at it inside of. Oops. So I don't have video. I'm gonna take okay. No. Dash debug. Okay. Here on my debug. All right, we'll fire this one up first. We'll put a breakpoint in our outpost here. All right, and then let's clean that, put that guy on. All right, so now we've got to our outpost. We've got our set order. Oh yeah, again, once again, remember to attach. So now I'm in a separate application. I'm in my outpost application. So the difference here, having split this out, did a couple of things. Let's do view, appearance, enter presentation mode. So now I'm making my order and I have sleepy time as my new method. You can see this is a little bit different, right? And so I go into this method, which I'm just doing the calculate delay, and then I return this new order. And this time, the way I'm returning things is by sending it back out. So incoming, this is just the Quarkus syntax. I'm listening on this Kafka topic called barista in. I'm running my logic, and then I'm sending it out on a topic called order up. And this is why I say I'm getting my local host name instead of a Star Trek character. But I've split this out, and then I've got my own domain objects here. So I have an order in, right? I've got my own domain objects. I've got my order up object. A Java record's a great way to do this, right? Because it's an immutable class. And so now from my the monolithic part of my application, what was that? This guy here. The only change I have was I went to this barista outpost. So now what I'm doing is, instead of doing any kind of processing here, I just pop this onto my Kafka topic. And so now we're able to extract this. This implements the exact same API. The rest of the application doesn't have to be changed at all. And chat question. Yes, source code for these projects. Absolutely. Source code for these projects. GitHub.com. Quarkus Coffee Shop. You can find there's a bunch of other stuff on here. I think I should probably make this a little bit better, but the GitHub IO documentation site should walk you through this at least reasonably well. Let me put this back in chat here. Here you go, Marcus Coffee Shop. Also, again, my contact stuff. If you want to reach me, if you have any questions, need any help getting any of this running or anything, this. Or on most social media, you can find me there. So feel free, if you run into any issues, be sure to ping me. You can also open an issue on here too. But yeah, so feel free to ping me if you have any other questions. And I think that's right up to object. Why would you? Okay, so one question: all the order business logic is encapsulated inside of the order object, the entity. Yes. Why would you want to embed all the business logic inside a static method of a database entity? Even the fact that you're returning an order in result, not just order shows or something off. Okay, so factory pattern is certainly a way you could address that because I'm using DDD, right? And the idea behind in domain-driven design, the idea is you want the entity to incorporate the business logic so that you can then pop other things around that, right? So it doesn't spread into the other classes. One of the problems you would have, like, let's say if we build, like traditionally, like when I first started doing Java, like struts was a big deal, right? And then Spring MVC took over from that. But you would have a post method would come in, right? And that post would perform some logic to create, your domain object, right? And then even if you pass it to a repository, the logic to create that object is encapsulated inside of this REST interface, right? But then let's say that I wanted to add some other type of interface. Well, now I'm going to have to duplicate that logic, right? It's going to go into two places. So the idea is we want to put all that logic in one place. We put it in that one class. Anybody on the team now knows, we can go, if we're going to change the logic around creating orders, in this case, we go into the order class, right? If we're going to change object around, any of the logic around what the barista is actually doing, we go into that barista class. And these other names mean something. So like I mentioned, the service is going to orchestrate things. It's not going to actually do the persistence itself, but it's going to call the method, right? It's not going to actually, create the object itself, but it's going to call that method. And that way the service can then be injected into a REST endpoint, a class listening to Kafka, a class listening to JMS, or anything else.